All right. So, hello everyone. Am I audible to all of you? Please let me know. Yeah, fine. So, welcome back to this particular channel of Pradhan Academy. Okay. So again, we are back with the topic of most important questions, right? You know that we have already covered or finished the entire syllabus for class 12th CBSE board examination preparation, right? So today, let us now start with the top 10 most important questions that I feel that are very much important for your CBSE board examinations. Okay. So if you are someone who is watching the lectures from this particular moment, I would request all of you, please like the video, and if you are new starting from today, please subscribe to the particular channel and hit the bell icon. We are basically going to come every day live with different contents, and we are basically going to deliver content which is basically important for the CBSE board examination that is upcoming on 8th of March. So these all our lectures are basically available for free, and they are very much useful and helpful for your CBSE board exam preparation. So I have already secured 100 upon 100 in my CBSE board examination. So I am basically there to guide you with all your important doubts and important questions. Okay. So that you don't miss out on any particular topic and you help or guide your preparation in a very particular scheduled manner. Okay. So let's start with this particular session on where we are going to discuss about the top 10 important questions. So if you are new to this channel, make sure that you start watching you have already watched all the particular lectures that I have taken on different topics. Okay, so you can definitely go to the channel and you can find under the live tab, you will definitely find all the chapters of maths listed down. So make sure to cover all the chapters of the maths listed down from there. Okay, so with that particular thing, let's get started, and I will be discussing the most important questions, and you will see that all these questions that I am going to discuss are really important and very easy. They are just about calculations or some small kind of tricks. So if you just watch this particular lecture and if you just come and discuss all the important questions, you're definitely going to secure full 80 upon 80 on this particular paper. So I have taken up all the sample paper, I have gone through the entire previous year paper. So with this I have come some with a statistical analysis that I feel that these types of problems are very important and they are definitely going to come up in your board examination. So whenever you are sitting for the board exam and you're turning your question paper, you will definitely see that set of problem will be repeating in your set of CBSE board exam paper. So with this, let's start with this session. So this will be a kind of a marathon session. So stay tuned for this part. Okay. So if you are starting to watch this lecture, please have some bottle of water and take a notebook and let's start with this, and with the aim that we are definitely going to crack the CBSE 2025 paper. Right. So I will be the instructor for this particular course, and let's start and let's see what are we going to discuss over here. So today our goal is basically to discuss about the top 10 important problems of CBSE 2025 paper. Right. So I will be almost telling you all the important questions that are going to be coming up. Okay. So with this part, you can definitely see that the type of question that I'm going to say you will be exactly the same question that you're going to see in your paper. Okay. So that is what I have done. I have done a wonderful statistical analysis of all the questions that has been repeated and all the concepts. I will list it down in one particular place. So if you please let me know in the live chat if it is clear or not. And can we start with this part? Please let me know first of all in the live chat that can we go with this part. So I hope you have understand, right? So if you haven't liked the video, please like it. Okay, I'm coming up daily and helping out with your CBSE board exam preparation. I will see out that when you actually go to the paper, you will feel that what all things I have already told you are the same thing that are basically coming up, right? So you can see that I have helped you a lot of time, right? So please consider liking the video, okay, and just subscribe to the channel, okay. So, and one more thing I would like to have your opinion on is basically if you feel that I should come up with more of these kinds of videos, then definitely comment that in the comment section after the video is over, after the session is over. Also, you can like in the comment in the live chat also, okay, so that you feel that these particular contents are helpful for your preparation. And I know these types of contents are definitely helpful because if you are someone who have just completed the entire revision or completed the entire syllabus, then they must be looking for the important problem or important set of problem for practice, right? Now I can guarantee you that if you just practice on these problems, you're definitely going to be clear with all of your concepts, all of your doubts, and you are basically going to crack the 2025 paper. Okay, so I will do the entire syllabus revision. Okay, not entire syllabus revision, if not, but we will pertain to almost covering the entire syllabus. Okay, we'll understand some different techniques or of solving a same problem. Okay, also we will discuss on the some exam patterns and paper analysis. So that is what we actually will be doing up in this particular session. So let us start with, first of all, little bit recap on what we have already studied in different chapters. Okay, so I have taken out some of the important concepts that I wanted to revise with all of you, so that you are basically good to go with the questions. Okay, so let us start with a very simple concept on applications of derivative. And now with this particular concept of application derivative, I will be explaining you how you can use this particular concept of application derivative to solve problems of functions of the continuity differentiability, as well as of the questions of applications of derivative, right? So we will be basically having a package kind of question, so that's what we're going to discuss over here. So let us start. So basically we start with the applications of derivative part. So what is basically said at that derivative is basically nothing but a rate of change of a function with respect to a given measure, right? So if you see over here, so what we can do is that we can represent the derivative. So if I have a particular function y is equal to f of x, right? So what we know that with the given input x, the output is y, right? So if I want to know what is the variation in the output y with the given variation in x, so if I know the variation in input, so our x is basically the input, right? So if I know the variation, if I know the variation in x, then what is my variation in output? That is my problem, right? So therefore, derivative is the simplest measure to understand that what is my behavior or variation in the y with the given known input variation in x, right? So what we do over here, we basically try to find out the derivative of y with respect to x. We also note write this as f dash of x, right? The first derivative as f dash of x, right? So what does this basically means is that the rate of change of in various fields of applied mathematics, okay, one of the question is to know the rate at which one variable is changing with respect to the other, right? So the rate of change of naturally refer to time. The rate of change basically refer that rate of change of any particular unknown quantity with respect to time. But we have the rate of change of with respect to any other variable as well, right? So for example, I have a very interesting statement over here written that an economist may want to study how the investments changes with the respect to the variation in the interest rate. Now if you're someone who is on the commerce background, you might, if you have taken a math, you can relate to this particular statement. Okay, so that economists want to know that the investment change with respect to the various interest rate. Similarly, a physicist wants to know that, someone who is from a science background, the physicist wants to know that how small change in dosage can affect the body's response to drugs, right? So what if I change just minute amount of dose of the drug, then what is his body's response to the particular drug? That is a concept that what physician does, right? Similarly, a physicist wants to know the rate of change of a distance with respect to time for describing about the motion of a body. Similarly, now these all questions are basically interpreted and answered with the help of derivative. Okay, so what we basically need to learn over here is that the average rate of change of a function with respect to a particular interval over the x which is varying can be simply given out by the difference of the function of value at that particular interval. Okay, so if I want to find out that for a change in x from a to a plus h, what is the average change? The average change will be f of a plus h minus f of a divided by h. But if I want to know what is the instantaneous rate, now this is very important. What I basically want to know is basically called as the instantaneous rate, right? So if I want to know what is the instantaneous rate, I will just tend the value of h to a very small minute number. So if I tend the h towards very small number, then whatever I am getting, that is basically defined as, so I will get limit h tending to 0 f of a plus h minus f of a divided by h, right? So provided that the limit exists, so if I say the limit exists, then this is the definition of what we have studied in the chapter of differentiability, that is, this is basically dy by dx, or it is basically f dash of x at that point 0. Okay, so since we are putting h is equal to 0, so therefore at any point x, okay, right? So this dy by dx is therefore defined as, so dy by dx is therefore defined as limit. Now let us say I'm basically calculating at a point x equal to a. So I will write limit x tending towards a, and I will take the slope of the chord. And when I tend that particular point x towards a, then it is mostly becoming the tangent. So what we will see, the derivative is basically nothing but a slope of the tangent at that particular point. So this is basically coming out as f of x minus f of a divided by x minus a, right? So this is what the definition of derivative of x looks like, right? So this part is clear, right? Please let me know in the comment section on the live chat. Okay, is it clear? Is this clear or not? Please let me know. So with this part, let's move to the next definition. That is basically we are going to revise that concept of tangent and norm, right? Now you have basically understood that derivative at a particular point basically means the slope of the tangent, right? So therefore, I can simply write derivative dy by dx at point x equal to a is basically nothing. So which we write it as f dash of x equal to a. It is basically the slope of the tangent, right? So if we try to understand graphically, let us say we have a particular function like this. So we see an arbitrary function like this, right? This is called the y is equal to f of x, right? Now let us say I take a particular known point x equal to a, and I take a particular some point which is in the neighborhood of x equal to a plus h. Okay. Now I have not putting any condition on h. First of all, let us try to understand what is basically this is that now if I try to form the chord joining these 2 points, if I try to find this chord joining these 2 point AB, so you have understood from your simple equation of straight line, you can simply write this equation of chord, right? So but I'm not interested about find out the simply this equation straight line. So but instead of that, if I need to find out what is the slope of this chord, so if I want to find out slope of the chord, if I want to find out slope of the chord AB, then I can simply write the slope of the chord AB as f of x equals to a plus h minus f of a divided by a plus h minus a. So this is going to be equal to simply as, this part is going to be simply as f of a plus h minus f of a divided by h. Now this is going to be the slope of the chord. Now think of the situation that if I approach the value of x equal to a plus h towards x equal to a from the right hand side, now if I try to tend this value of x from point B to point A from the right hand side, now let us say we take a point B over here, then the tangent is, the chord is like this, right? But similarly, if I take this point B as much as possible, as closer as possible towards point A, then I see that this is nothing but it's almost becoming the tangent at point A. So it's becoming like the tangent at point A, right? So it is basically becoming tangent at A. Now when I basically making the tangent, that is when I'm tending the x value from x equal to a plus h towards x equal to a, I'm basically doing what? I'm basically putting limit such that your h is tending towards 0. Now recall from your earlier definition, this is basically nothing but f dash of x, right? So f dash of x is basically giving me what? It is giving me the slope of the tangent, because first of all I found out what is the slope of the chord, and once I tend this point B towards very close to point A, then that is basically becoming a tangent. So that is the slope of the tangent. So I started with slope of the chord and I ended up getting the tangent once I limited the value of h towards 0. That is, I tend the value B, point B, to as much as possible, as close as possible towards point A. Is this part clear? Is this part clear? Please let me know. If you haven't liked the video, please do like the video. Okay, this will be a very wonderful help for all of us. Okay, because you can see that this is the kind of lectures I'm providing just for free, right? So these are going to be very helpful and crucial for your ultimate board exam preparation also. Okay, so please make sure that you watch these sessions till the end. Okay, and please like and subscribe to the channel. Okay, so I am coming with all this effort just for free. So make sure that you like and share, as well as share this particular content with all of your friends, okay, who are basically preparing for this exam, or someone who is in class 11 then starting your preparation for class 12. You can definitely share this particular channel to them as well. So once we know the slope of the tangent, so if you recall from the point slope method of a straight line, or finding out the equation of straight line, so once you know the slope of the straight line, you can definitely write the equation of tangent at a particular point, let us say x1 comma y1, as simply as y minus y1. So y minus y1 is basically equal to slope of the tangent into x minus x1. So here I will just put the value of the slope of the tangent, right? So from here I will just put the value of the slope of the tangent, and this is how I am going to get the equation of tangent, right? Now if you recall that whenever I have two perpendicular lines, so one line having slope m1 and the other line having slope m2, so if they are perpendicular, then m1 into m2 is basically equal to minus of 1, right? So this is something that you have studied in the chapter of straight lines from your earlier classes. So angle between two straight lines is given by tan inverse of m1 minus m2 divided by 1 plus m1 m2 mod of it, right? Because we want to get the acute angle. Okay, so if the angle is 90 degree, then the denominator should be equal to 0. So for denominator to be equal to 0, the thing is 1 plus m1 m2 should be equal to 0. Therefore I will get m1 into m2 is equals to minus of 1. Okay, so therefore the slope of the normal is basically going to be minus 1 upon the slope of the tangent. So from there, if I have the slope of the tangent and slope of the normal, so from the slope of the tangent, I can just simply calculate the slope of the normal. And once I get the slope of the normal, I can just put that into the equation of the straight line to find out the slope of the equation of the normal. So if you can look at the figure, it is very clear from this particular figure. Okay, so I hope this is clear to all of you. Is this clear to all of you? Please let me know. I'm just looking through your live chats. Please let me know if you have any questions. And if you want to get a free mentorships or personal tuition for JEE Mains and Advanced, please contact the given number that is floating on the live chat. Okay. So if you want to get one-to-one mentorship from me and want to prepare for your mains and advanced exam, do contact the given number. You can contact the number on the WhatsApp and you can get my personal mentorships. Okay. So you can see the live chat. You can definitely get to that number, contact number. Okay. So once you understand this part, so I hope this part was very simple and clear, right? Okay. So I hope this part is clear. Now let us proceed. So if this part is clear, now I will talk about one important question that I feel that is basically very much of a probability or chances of getting repeated in the paper. Okay. So if you just look at this particular fourth number problem, so you can see that is a simple problem from the concept of applications of derivative, right? So if you look at this particular problem, it is said that I have a function f of x, which is a continuous function on this particular closed interval a to b, and it is a differentiable function on the open interval a to b. So if the function is strictly increasing, then what should be the condition? So if you recall from the concept of derivative, I hope my screen is visible to all of you, right? Okay, this part is clear, right? So if you recall from the concept of derivative, so for a particular function to be strictly increasing, let us say it is strictly increasing like this, right? So for a particular function which is basically in between the domain x equal to a to x equal to b, right? So this is basically x and this is basically y. So if it is bounded between the domain x equal to a to x equal to b and it is a strictly increasing function, what can you do? So let us say I take one intermediate point c1. So c1 is basically lying in between a and b. Okay, so let us say I took an intermediate point c1 in between a and b. Now what I'm going to do, so if I take an intermediate point c1, what you can find out, so let us take one more intermediate point c2. Okay, so what we see over here is that both c1 and c2 are basically intermediate to this interval. Okay, so if you just apply a simple inequality over here, is that f of c2 minus f of c1 is definitely positive, because if it is an increasing function, the value must also go on increasing. So you can see f of c1 and f of c2 is basically greater than f of c1, right? So what you can see, this part is basically increasing. So for increasing, this f of c2 should be greater than f of c1. Therefore, if I divide it by c2 minus c1, this is also going to be positive because c2 is greater than c1. Now, if I try to tend this c2 as close as c1, so therefore, if I put limit c2 tending towards c1, then this is nothing but the concept of differentiability, right? So if you just recall from the derivative formula, so this is nothing but This is nothing but f dash of c1. So what I am getting, that f dash of c1 is greater than 0, right? So if you do the same exercise for taking some other point c3, you will also find that derivative of c2 is also greater than 0, derivative of c3 is also greater than 0, right? So therefore, what you understand that for a particular function to be strictly increasing, what is the most important criteria is that f dash of c should be greater than 0, not greater than equal to, it should be greater than 0 for all c basically belonging between a and b. So if c is lying between a and b, it must be strictly greater than 0. That is the condition for strictly increasing. Okay, so the condition of strictly increasing is basically given by this part. Okay, so I hope this part is clear. Okay, so f dash of c should be greater than 0 for all c lying between a and b. So from this, you will see that the option number B is the right answer to this particular question. Okay. So option number B is going to be the correct answer. I hope this part is clear, right? Can you please let me know if this part is clear or not? Is this clear? Okay, Naresh, is this clear, right? Okay. So I hope this part is clear right now, right? So let us try to proceed with the next important problem that I feel that is very much crucial for your paper is these problems. Okay, that is you are given or provided with a vectors. Okay, with the two unit vectors, right? So let us say in this, let us now focus on this problem number 7. Okay, now this is a problem that I feel that is has much probability of getting repeated in the paper. Okay, so if you have, it is said that in the question, let us say that theta is basically defined as the angle. Let us say theta is defined as the angle between two unit vectors given as a cap and b cap, such that I have sine theta as equals to 3 by 5. Now for solving this problem, you just have to use simple trigonometric identities. So how are we going to do that? Let's try to understand that when we basically perform dot product. So first of all, let us try to recall on the definition of dot product. So if I have two vectors a and b which are non-zero, then dot product of these two vectors are simply given as mod of a vector into mod of b vector into cos of theta, cos of angle between the two vectors, right? Now one more thing to understand over here is that how do you calculate the angle between vectors, right? So in order to calculate the angle between vectors, it is very crucial to understand that two of the vectors must be coinciding at the tails, or then the acute angle which is formed over here, that is basically the angle between vectors, or we can also find the angle between the vector by the coincidence of the head of the vector. Okay, so if we just try to coincide the head of the vector, then that particular angle or acute angle we are getting, that is also called as the angle between vectors. So any of this definition will work, right? So if we just try to find out that for two unit vectors, we need to find out what is cos sine theta. So we are provided with already sine theta is given, right? But for performing dot product, I need to know what is cos theta, right? So let us now try to apply the condition or in the simple identity, that is sine square theta plus cos square theta is equal to 1. So from here, I'll get cos of theta is basically square root of 1 minus 3 by 5 whole square, which is basically equals to 4 upon 5, right? So therefore, I will get cos of theta is equal to 4 upon 5. Now, if I have cos theta is equal to 4 upon 5, then my dot product of two unit vector a cap dot b cap is basically equal to cos of theta, and which is basically nothing but equal to 4 upon 5. But since we have a square root and we don't know whether we need to provide the acute angle or not the obtuse angle. So we just provide it over here plus minus sign, right? So that's how your answer to this particular problem is going to be equal to plus minus 4 upon 5. So as you can see, this is basically going to match with option number C. So your option number C is going to be the correct answer to this particular problem. I hope this is clear. So I feel these problems are going to definitely repeat. Okay. So if you look at the 2023 paper, if you look at the 24 paper, if you look at the 22 paper, you definitely can see one question which is basically of this type. Okay, where you have to perform the dot product and calculate the angle, or angle information is given and then you have to find the vector or maybe the dot product of that. Okay. So these types of problems are very much crucial and important for your upcoming board exam, right? So please make sure that you revise these types of problems. These are one of them very, very important. Okay, let us now try to move to the next problem. So next problem which I feel that it is very important or has the probability of getting repeated is basically this particular problem. Now for solving this problem, let us try to, no, not this one, sorry, ninth one, right? Yeah, ninth one. So basically let us try to understand the ninth problem, right? So for solving this ninth problem, let us try to recall on what we have studied in the chapter of vectors. I will come to this problem number 8, but let us first of all try to recall the ninth problem, because problem number 8 is also very important, but for that I have some definition prepared for it, okay, and I have some formulas sheet also ready for it, so I will just go through that and then I will tell you that. But before that, let us try to understand that for a given line, if I have the direction ratio of the vector given as L, M and N, which is the direction cosine. Okay, let us say these are basically direction cosine. So instead of giving the direction ratio, I am being provided with the values of the direction cosine. Okay, so if I have the direction cosine, now let us try to recall on what is basically mean by direction cosine. So if you recall that in a 3D geometry, in a 3D coordinate space, if I have any particular line joining the origin or a point joining the origin, which is called as a position vector. So the angle which this particular line makes with the x-axis, y-axis and z-axis are therefore called as the given angle. And if I take the cos of these angles, then those are nothing but they generally represent the direction cosines. So therefore, what I see over here, cos alpha, cos beta and cos gamma are nothing but the direction cosines, which are written as DC. So if you just try to find out what is cos alpha, cos beta and cos gamma, you will find out that those particular things are nothing but the projection of this unit vector OP. So let us call this O, unit vector OP onto this x, y and z respectively, right? Also along with that, we find out that cos of alpha is basically equal to x upon square root of x square plus y square plus z square, right? And similarly you can do the rest for cos beta, cos gamma. But what we have found out that if I try to find out the sum of the square of this direction cosines, we'll find out that this particular thing is equal to 1, right? Now this is a very, very important criteria that we are obtained, right? So if we in the question it is already provided the direction cosine of the given line are as root 3k, root 3k and root 3k, then what is the value of the k? So if the direction cosines are given as root 3k, cos alpha is root 3k, cos beta is root 3k, cos gamma is root 3k. So I simply just plug it into this particular equation, and from here I will get this as value as root 3k whole square into 3 is basically equal to 1. So from here I will get 9 times of k square is equal to 1, which will basically give me the answer as k is basically equal to plus minus 1 upon 3. So from here I will get the value of k as basically equal to plus minus 1 upon 3. So what you can see here to find out the value of k, which you can see that the option number D is the right answer to this particular problem. So your option number D is basically the right answer. I hope this particular solution is clear enough, right? So if you just recall from your initial lectures on 3D geometry, you can definitely answer this problem very simple, in a simple manner, right? So this part is clear, right? Please give me a thumbs up if this part is clear or not. This part is clear, right, Naresh? Okay, Naresh, great. So you are also coming up for this particular class. That's good that you are basically interested to prepare nicely for a paper, right? So I hope this part of the solution is visible to all of you, right, over here, right? So with this, let's now try to understand one more important problem that I feel is basically has the chances of being asked or repeated in the paper is basically this particular problem, problem number 10. Because this is a problem which I feel like it can be asked in some different manner also, but it is very important to understand the main criteria of linear programming, right? So in linear programming, what we are doing, we are just doing optimization, right? We are either calculating maxima or minima along a given condition, right? So if you recall from your chapter of the linear programming, what we have dealt out is basically we have multiple linear equations in two variables, and along that particular line we have a particular subject equation or the equation which we need to maximize or minimize, right? For that maximize or minimization, what we do, we basically found the bound of the region, and at the end points we try to find out what is the maximum or the minimum value we are getting, and that will give me the value of the linear programming, right? So that is the idea that we do. So if we read this problem, so what we see, the linear programming problem deals with the optimization of which kind of function, right? So please tell me if you know this answer. Tell me, what do you feel that linear programming problem deals about optimization of which types of functions? Let me know. So what do you think that linear optimization problems deals about? What kind of functions does linear programming deals about? I'm waiting for your answers. Let me know what kind of problem does linear programming talks about. Okay, so let us try to recall that in linear programming problem, we have a given region. First of all, we have to find out the bound of a given region, right? So let us say our given region is something like this, right? Okay, so this is our given region what we have to bound, right? Which is our boundary condition. So inside this boundary condition, what we are basically doing, we have a function like z is equal to some a times of x plus b times of y, right? Let us say that I am purchasing x number of, so let us say I am having that x number of some, let us simple have example of like x number of objects, something like let us call as x as apple. Okay, now I am a fruit seller. Let us say that I am a fruit seller and I am selling two fruits, that x is basically apples and y is basically oranges. Okay, so each apple is costed a rupees per apples, and b is the cost of oranges. Okay, in rupees. Okay, now so if you need to purchase x number of apples and y number of oranges, the total cost of what I'm going to incur is basically going to be z is equal to ax plus by. And let us say I have a restriction that because of the ongoing market or the ongoing agriculture that is basically done now, we are basically having some limit on the number of apples or oranges that I can purchase at max. So what we are basically doing in the linear programming is basically we are trying to minimize the cost with maximum number of outputs. So if we look at this maximize problem, so basically it is an optimization of a simple, so you can just look at z is basically a kind of a linear function. So because it is a degree 1, so it is basically dealing with the optimization of a linear function, right? So that's a simple problem that I feel like it has a potential of being repeated again. Okay, so linear programming problems define or is related to the optimization of a linear function. I hope this is clear. I hope this is clear to all of you. Please let me know if this is clear or not. Right. Now the next problem that I feel has a chance of getting repeated is this 13th problem. Okay. Now this type of problem where you have to apply the chain rule for derivative is a important problem. Okay. So you just use a simple chain rule. Okay. Try to solve this problem and let me know in the comment section what you are getting the answer. You have 2 minutes time. Please try to solve this problem. Please try to solve this problem. You have 2 minutes time. Solve this problem and let me know what you are getting as answer. you just have to apply the chain rule. So if I let you revise the chain rule, so let us say I have a composite function like f of g of x. Let us say y is equal to f of g of x, and if I want to differentiate this y with respect to x, it is basically given as y dash of g of x multiplied with g dash of x. That is how we are going to differentiate a composite function, and this is called as chain rule. So please try to simply apply the chain rule over here and tell me what is the answer you are getting. Please apply the chain rule. So, if I see the function is basically y is equal to sine of x square, right? Sine of x square, right? Now, if I just differentiate this with respect to x, it is basically, first of all, derivative of sine is basically equal to cos, and cos of x square multiplied with derivative of x square, which is basically equal to 2x, right? So, therefore, I'll get the derivative of y with respect to x as cos of x square into 2x. Now, I need to find the derivative at a particular point x is equal to root under pi. So if I just put x is equal to root pi, I'll get this value equals to minus of 2 square root of pi, right? That is my option number C. That is basically the correct answer to this particular problem. So option number C is going to be my correct answer. I hope this particular problem is clear. Please let me know if this problem is clear or not, right? Now let us come back to what we were discussing over here, right? Let us try to discuss one more thing is over here is that now whenever you are basically to find out the angle between two curves, right? Now let us say I have two curves arbitrarily like this, right? Let us say they are intersecting something over here, or let us say I have a curve like this which is intersecting at a particular point. Okay, so in order to find the angle between two curves, let us say it is intersecting at point C. Now in order to find the angle between two curves, it is basically defined as the acute angle between their tangents or between their normals at their point of intersection. Okay, so first of all I will find out the tangent at C to the first curve and the tangent at C to the second curve. So let us say this is the tangent 1 and let us say this is tangent 2, right? So the angle which the tangent makes at the point of intersection is basically defined as the angle between the curves. So from here you can see that if I know that the tangent slopes m1 and m2, I can simply write the angle between the tangent as tan inverse of, or angle between the curves is simply as tan inverse of m1 minus m2 divided by 1 plus m1 m2, and we just put a mod over here because we are basically interested to find out the acute angle, right? So we need to find out what is the acute angle that the curves are making. Is this clear or not? Please let me know. Is this clear or not? Is this clear or not? Right. So with this, we will also talk about one more important theorem, that is the Rolle's theorem and the Lagrange's mean value theorem. Okay. Now these are the two important theorems in applications of derivative which are very much crucial for solving different sets of problems. Okay. Of applications of derivative types. Right. Now, if we look at the statement of Rolle's theorem, now many times this question will be coming up in an exam that you have to prove that given function satisfies the Rolle's criteria. So what are the criteria of Rolle's theorem? Is that for the function to satisfy the Rolle's theorem, right? For a function to satisfy the Rolle's theorem, the function must be first of all continuous within the domain, within the closed interval a to b. Now, and the function must be derivative, that is f dash of x must exist at every point in the open interval. That is the most important differences. Okay, so the function must be continuous in the closed interval and differentiable in the open interval. And if it is so, and also we need to check that the endpoints, the value of the function at the endpoint must be equal, right? And if we are having these three sets of criteria valid for the given function, then only I'll say that the Rolle's theorem is valid. And if the Rolle's theorem is valid, therefore the theorem says that there exists a point x equal to c such that now this particular point c basically lies inside the domain. Okay, inside the domain A to B. So there exists a point C which is lying in between A to B, and for which I will have f dash of C is equal to 0. Okay, so this is the statement of Rolle's theorem. Please carefully go through the statement of Rolle's theorem. It is very, very crucial. Okay. So this part is clear. Now the next part that you need to discuss is the Lagrange's mean value theorem. Now in respective of the Rolle's theorem, in Lagrange's mean value theorem, we have to satisfy the first two criteria, but we are not satisfying the criteria for the last point. That is, if at the end point, the function value at the end point are may not be equal, right? So what does this statement of Lagrange's mean value theorem says there? So Lagrange's mean value theorem is more like a general case of a Rolle's theorem, or we can also tell it like that, that Rolle's theorem is a special case of Lagrange's mean value theorem. This is a very important proof that you can also come up in the exam. Okay, so this can be a proof. Okay, that Lagrange Rolle's theorem is a special case of Lagrange's mean value theorem. Okay, so you can prove this, right? So in the Lagrange's mean value theorem, it says that if the first two criteria are satisfied, then there is a point C which lies inside the interval A to B, for which the derivative at C, that is the slope of the tangent, is equal to the slope of the chord joining that there is existing one point for which the slope of the tangent at that particular point is equal to the slope of the chord joining the end points. Right. So that is what is basically mean geometrically. That is the slope of the tangent or slope of the secant line joining the curve at x equal to A and x equal to B is equal to the slope of the tangent line drawn to the curve at x equal to C. Okay. So I hope this point is clear. If this is clear, please let me know. So therefore, what you can see that in Rolle's theorem, that f of A and f of B is equal. So if they are equal, then you can see this particular derivative is coming out as 0. So therefore, you can say that the Rolle's theorem is a special case of a Lagrange's mean value theorem. Now this proof can be asked in a paper. So definitely please go through this particular proof. Okay. This is a very simple one. I hope this is clear to all of you. Is this clear or not? With this, let us try to discuss about something about the differential equation, right? So now before we move to the differential equation, the most important thing that you can come up in the differential equation is basically the solution of homogeneous differential equation, right? Now this is the most frequently asked problem, right? Where we basically have to approach the solution of homogeneous differential equation in the manner by putting this y by x terms to some variable v, right? And then we just change the derivative or differential equation of the form dy by dx to the form v plus x times of dv by dx. Okay, v times x times of dv by dx, right? That is how we are going to change the problem to v plus x times dv by dx, right? Okay, so generally forms of these homogeneous types of functional equation are generally solved by this way, right? So this is a very important form. Now how to check for homogeneous form of differential equation? So maybe you say that you have a differential equation which is given as f of x comma y divided by g of x comma y. What we'll put to check for homogenization or homogeneous function, we'll put that in place of x we'll put lambda x, and in place of y we will put lambda y, and we'll check that are we able to get f of x, lambda x. This is basically so I am going to check out f of lambda x comma lambda y. Am I getting this equal to lambda times of f of x comma y? So if this particular criteria is satisfied or not, that is what I'm going to check for the homogeneous case. So if it is a homogeneous, it will definitely satisfy this criteria. I hope this is clear. So whenever you have an homogeneous problem, please assume this y is equal to vx and then you proceed with the solution. And then you will see that the homogeneous problem will simply stand out to be a problem of variable separable time. Now variable separable time is very easy. We just club the y with y, okay, and x with x. That is how you separate the homogeneous variable separable form and just integrate it, and that's how you solve the given differential equation. Now one more thing, you are definitely going to come across the only first order differential equation. Okay, so don't need to worry about the other orders of differential equation. Okay, Fine. Is this clear to all of you? Okay. Now, what is more important to look into is the form of the linear differential equation. So, generally, you will see that linear differential equation are of the form dy by dx is plus py plus is equal to q. And this is where p and q are basically nothing but they are the function of only x. Okay. P and q are the function of only x. Okay, now this is to be satisfied for getting a linear differential equation. Now, in order to solve linear differential equation, the most important thing is basically to get the integrating factor, right? So, integrating factor for a differential equation is basically e to the power integration of p dx, and so solution is basically given as y into integrating factor is equal to q into integrating factor dx. Okay, dx or like this. Okay, so this basically when we have the equation in the opposite form, or if you have the equation of this of the dy by dx, then it is y into, so let me write it over here. If it is the form dy by dx plus p times of y is equal to q, then the solution is simply y into integrating factor is equal to integration of q into integrating factor into dx plus c. That's how you're going to approach the solution, right? So with this, you can simply solve out this particular problem. So if you look at this particular problem over here, that where we need to find out the integrating factor of the differential equation. Now I feel that these types of problems are very much crucial for your exam. Okay, so if you just try to simplify this differential equation of the first order type, that is dy by dx is equal to dy by dx plus x sum upon 1 minus x square into y is basically ax divided by 1 minus x square. So simply the integrating factor is basically going to be the, so here the integrating, so let me erase this part. So over here integrating factor is basically going to become equal to e to the power integration of p dx, and this is what is my p, right? So therefore I will have e to the power integration of x 1 minus x square dx, right? Now what I will do, I will use simply substitution to solve this integral. So let us say I consider 1 minus x square is equal to t, then I will get minus 2x dx is basically equal to dt. So from there I can replace this as e to the power square integration of dt by 2 minus divided by t. So this will basically come out to as e to the power minus 1 upon 2 ln t, which is basically simplified as, and this part we simplified out as, so you just use a base changing formula, it is basically equal to t to the power, so 1 upon square root of t. So that is basically, and what is t? T is basically 1 minus x square. So from here you will get the integrating factor as option number D. I hope this part is clear, right? So option number D is going to be my right answer to this particular problem. Okay, now if you need to solve it, you can definitely solve it by using the simple definition over here. So you just apply this solution, you're basically going to get the solution of a linear differential equation, right? I hope this part is clear. Okay, so with this, I have discussed about the most important top 10 questions that I feel that are very much important for your CBSE board examination, that is upcoming exam on 8th of March. Okay, so if you have completed preparing all these problems, you can definitely be sure that you are definitely going to score full marks. Okay, now one more thing I would recommend to all of you is basically please make some short notes and keep on revising it every day. Now similarly, of these top 10 important problems, we are also going to meet again tomorrow, where we are going to discuss the sample papers. Okay, CBSE sample papers, and we are also going to see how we are going to actually write the paper in form of the answer script. Okay, I will come up and I will show you how we are going to write the entire paper and how we are going to manage the entire time. So with this, I